Welcome to the SmartZone Network Controller demonstration series for SmartZoneOS 5. In this series, we'll be covering the new features available in SmartZoneOS 5. In this demonstration, I'll be covering the new option that allows access points to capture traffic and either store that traffic in a local PCAP file or forward the traffic to an external packet analyzer using Remote Switch Port Analyzer or RSPAN. When monitoring wireless interfaces, you can filter on specific MAC addresses and message types that include management, control, and data traffic. And when analyzing wired interfaces, you can select which interface to monitor, apply MAC address filters, but no other filters are available because management, control, and data traffic types are only 802.11 functions and don't exist in the Ethernet interface. So let's take a look at how this is configured. So we'll start by logging into my virtual smart zone. And once we log in, you'll see this is the Virtual Smart Zone Essentials Edition. This functionality I'm going to show you is the same whether you're running the Virtual Essentials Edition or the Virtual High Scale Edition or any appliance that's capable of running SmartZoneOS 5. So looking down at the system info down in the corner, you can see I'm running version 5.0.0.0.675. This is the initial GA release of SmartZoneOS 5, and this is the first release where this functionality was available to be configured on an access point. So we start by configuring the access point itself. So we'll go to the Access Points tab on the left over here. We'll wait for this to populate, and when it does, you'll see I have two access points in my network right now. I have an R510, which is up and online, and I have an R500 that's offline. The reason I'm doing this is for this demonstration so that I can force all the traffic through one access point so I can show you the different capture capabilities. On this particular access point, I have two clients. One client is connected at 5 gigahertz and one client is connected at 2.4 gigahertz so that we can potentially show the different traffic on the different interfaces if we wanted to capture from any one of those. Now, we start a packet capture in two different ways. One is available to us here at the More option. This is only available if we selected and highlighted the access point and clicked on it. Then we get the More and Packet Capture. This will open a window to start a packet capture for us. But another option to do the same thing is down here on the Health tab. We can click on the Health tab, and once this populates, we're going to have a packet capture option down here. Both of these paths to opening the packet capture utility bring you to the same place and start with the same configuration options. So we'll go ahead and take a look over here. We have two different capture modes. We have Stream to Wireshark, where we can stream traffic to a remote Wireshark station, or we have Save to File. I'm going to start with Save to File in this demonstration, and then we'll show you the Stream to Wireshark a little bit later. But when we click Save to File, we get some options for what we want to capture. First, we have to select the interface. If we do 2.4 gigahertz, I can capture one of my machine's traffic. In your case, it'd be anything on the 2.4 gigahertz band. We can do the 5 gigahertz band, which is selected here, or a wired interface. Now, if I select a wired interface, some of these configuration options change. Each of these, you'll notice, has a MAC address filter option. So that doesn't change. When we're doing a save to file, we can filter on a specific MAC address in the data stream and only capture traffic to or from that MAC address, then forward that off to, or put it in the file to be looked at in Wireshark, so we don't have to see all the traffic in the network. And of course, with the wireless interfaces, we have frame type filters where we can select whether we want to capture management traffic, control traffic, and or data traffic, and any combination of these. So if I didn't want control traffic, I could turn that off and still filter on management and data traffic. Or if I only wanted customer data traffic or user data traffic, I could turn off all management as well. So I turn off management and control and I only see the actual data. Now that's the same options for the 5 gigahertz band. Nothing changes there between the two. We can just only capture on one of these frequencies at a time. We can't capture on both. Now if I select the wired interface, I can select the wired interface here, and then I get to still have the MAC address filter, which in all these cases will be put in a hexadecimal format separated by colons like shown here in the example. And then I can select which port I want to capture on. Now different access points have different port configurations on them and port options. So this is an R510. I have two ports on it, LAN 1 and LAN 2. LAN 1 is the power over Ethernet port, which is the one I'm using to power the device and the one I have it for connecting to the network. I don't have LAN 2 connected, so in my demonstration here, we're going to leave it at LAN 1. So LAN 1 is fine. We're looking at the wired interface. Now, the bonus of the wired interface in some scenarios of when you want to capture traffic is that in my scenario, if I monitor the wired interface, I see traffic from both of my clients. Remember, I have a client on the 2.4 gigahertz band and a client on the 5 gigahertz band. If I were to capture only on the wireless interface, I could only look at the traffic of one of those clients at a time. So by going with the wired, in this case, it gives me the option to be able to look at both of them, and that's what I'm going to do here. So we start this capture by just clicking the start button. And what we do when we start this, the access point has 20 megabytes of memory available for it to store these capture files. Now the status switched to capturing, so it's actively capturing whatever packets it's seeing over the air, or frames that it's seeing over the air, and it's capturing those and putting them in a local file. It's going to be a PCAP file that then gets compressed, but it's actually going to store them in two separate files. There's 20 megabytes of space. It's going to write 10 megabytes to one file. When that one's full, it's going to write 10 megabytes to the other file. And then it's going to just keep writing over one another of those files as it captures data. Now this will automatically stop after 30 minutes, so you don't have to worry about this running forever and continually filling up that space and writing and offloading packets to these external files forever. But it'll stop automatically at 30 minutes, and then you'll get the option to download the file. Now, with me, I have a couple of different streams running. I have some data running through the network, and I'm trying to fill up these files so that I can show you the different files that get collected. So what I'm probably going to do here is speed through the next little bit of this demonstration and get us to where we have enough data captured to show you those files. Then I'll come back to you and I'll show you what we've captured. Okay, enough time has probably passed for us to collect some good data here, so I'll go ahead and stop this. And while I hit stop, it's going to start churning on this data and compressing it together and putting it into gzip files for us to be able to download quickly and take a look at. And once that's ready, we'll get the download button as shown here. So we'll go ahead and download this. This is where I want to save it. I have another one here that I captured earlier. You'll notice that it'll automatically just append the -1 at the end of it. This is a Windows function, so different operating systems may behave differently, so you'll want to pay attention to this so you don't accidentally write over old files that you've downloaded, because it's a possibility, because these files and the file themselves and the directories they create are the MAC address of the access point. So if you capture from the same access point multiple times, there's a possibility you could write over old files. So you'll want to manage those yourself and make sure they're taken care of. So I'll go ahead and save that. Okay, so here's our file. I've gone and cleaned up the old stuff that was in here, but the demonstration will still work as shown. I'm going to extract this stuff. You can use a lot of archive utilities will be able to extract tar gzip files. So this is going to extract the tar file from the gzip, and then once we extract that, we can extract the tar file and get our directory. And again, the directory is the MAC address of the access point that we collected this info from. Now inside this directory, I'm going to have two PCAP files. I've got one that's basically that 10 megabyte limit, reaching right up to that threshold, and then began writing to the other file. So let's go ahead and open this one up. Now, by default for me, this will open in Wireshark. You might have a different packet analyzer available to you. Wireshark seems to be the one that almost everyone's using these days. And what you see here is regular raw Ethernet frames. So I captured on the Ethernet interface. So I'm looking at regular Ethernet frames. Now, if we were to capture on the wireless interfaces, we'd see 802.11 traffic here. And you'd have to be able to look into that traffic to see more of what's in the payload. But this is standard Ethernet. We've got our Ethernet 2 field with our source and destination MAC address, our type field telling us it's IP version 4. We've got our IP information here. We've got our TCP information here. And because most of this, as you can see, is TLS data, it's all encrypted, so we can't really see anything in the payload. Basically, what I have going here is I have these two stations that I have looking at video streams online so that I can generate enough traffic to be able to fill up these files for us. So that's how we capture traffic to a local file. It captures on the access point. Once it's at the access point, it'll allow us, when we stop that, it'll allow us to download that to our local machine to be able to analyze the traffic we've collected. That traffic capture will stop by itself after running for 30 minutes if it's not stopped by the user. And another note on that, it can only be stopped by the user that started it. So if you have multiple users on your SmartZone network controller running SmartZoneOS 5, the user who started the capture process is the only one that can stop it. No other user can. So that's just a side note for you to keep in mind when you're doing this. So we're going to jump back over to SmartZone. So back here at the controller, our window is still up. We still have the download option. It's telling us that it's idle and the file is ready for us. And we can download it again if we want to, or we've already got it here, so we don't really have to worry about that. Or we can start a new capture and it'll create new files for us, and we could download those if maybe we didn't capture what we wanted in the first capture. So the other option for us to do here is to stream to Wireshark. So let's go ahead and select that option now. So if I select Stream to Wireshark, on the wired interface, we'll look at that one first. I have the same options of capture interfaces. I have the 2.4, the 5 gigahertz, or the wired interface. The wired interface has the same options for which port, but you'll notice that the MAC address filtering on the wired interface is no longer here. You cannot filter on a MAC address on the wired interface if you're streaming this traffic to Wireshark. So the other field we have here is the Wireshark station IP address. So this is the IP address of the Wireshark station you're trying to forward this traffic to. It's not a required field, but it definitely helps to put in the specific IP address of the source so that it's not flooding this traffic across the network. Now, if we look at the other interface types, we can look at the 5 gigahertz interface. We still have the option to configure the Wireshark station IP address. We can do MAC filters again, so these are available on the wireless interfaces, but not on the wired interface. So we can still put in a MAC address to filter specific traffic to or from that MAC address on the wireless interfaces, and still done in the hexadecimal colon-separated format. Now, we also have the same frame type filters. We can still filter on management, control, and data. And again, any combination of those. If we only wanted management, we could turn off control and data. And those options are available to us. So what we'll do here is we put in the IP address of my Wireshark station. And that's the IP where I'm running Wireshark right now. I'll show you the Wireshark configuration here in just a moment. But what we need to do here to get this started is to actually start sending the stream before we start up Wireshark so that we can configure the remote interfaces that are going to capture this traffic. So let's go ahead and start this stream. So when I do this, I'm going to capture just on the 5 gigahertz. So I've got one machine, remember, one client on the 5 gigahertz, one client on the 2.4 gigahertz. I'm going to capture the 5 gigahertz client. So let's go ahead and start that. So what this is doing now is this is streaming traffic out to this IP address. So that streaming is moving. So I'm going to go over to my Wireshark station and do the configuration over there. So this is my Wireshark station. I'm running on Windows 10. It's available on Mac OS and Linux operating systems, so you can get it on each of those. But each of those comes with their own caveats on how you can configure the remote interface that you need to capture RSPAN traffic. So you're going to have to look through the guide for your version of Wireshark to figure out what you need to do to be able to monitor remote ports. So we're going to go over here to Capture, and we hit Options. And in Options, we want to go to the Manage Interfaces options. Again, this is Windows 10, so we want to add a new external interface or remote interface. So we'll go up here to Remote Interfaces, click on that, and you'll see we have a tab with several different interfaces available to us. Basically, the access point gives us every interface that's available on the system. The ones we care about are the Ethernet 0, Ethernet 1, Wi-Fi 0, and Wi-Fi 1. These are the ones that are associated with the interfaces that we have available to us to select. The Ethernet ones may be different on your access point. Remember, this is an R510 with 2 Ethernet interfaces, so you only have the interface options that are available for your access point. Basically, Ethernet 1 on this is ETH 0 is the LAN 1 interface, ETH 1 is the LAN 2 interface, Wi-Fi 0 is the 2.4 gigahertz, and Wi-Fi 1 is the 5 gigahertz. So those are the ones that you'll want to use when you're capturing here. So we just need to click OK on this, and once we click OK, we'll then be able to go over and start a capture on one of these interfaces. So now we see those interfaces populate here. Again, these are all the ones we talked about. We've got the Wi-Fi 1, Wi-Fi 0. We're capturing on the 5 gigahertz channel. So the one we want to capture on is Wi-Fi 1. So that's what we configured over on SmartZone on the SmartZone network controller to forward traffic over to this remote Wireshark. So we select that interface and hit start, and we immediately start collecting data from that access point. So the access point is actively forwarding data to this Wireshark station in real time. So we're real time seeing traffic that's going over the 5 gigahertz interface on the access point that we're working with, and it's actively coming in and showing us what's going on. Now this is all 802.11 information, so we're looking at Wi-Fi frames here. So if you want to look through the data and see what's underneath this forwarding layer, you're going to need to use some of the other tools available that are available within Wireshark and other external tools. So we can stop this here, and gives us the opportunity to look through a particular frame, look at the 802.11 information. We can scroll down here and we can see things like the channel it's operating on. We can see the signal strength and some other information that's available in 802.11. So we've stopped it over here at the Wireshark. We can come back over here to our SmartZone network controller, and we can stop it streaming this traffic since the receiver is no longer there to grab it. And we can let the access point stop worrying about forwarding this captured traffic. We can go back to our Wireshark and we can analyze the traffic we've collected. There's a lot of available options to us for how we're going to do this and what we're going to do with that data. But this really shows the capabilities, this new capability in SmartZoneOS 5 that allows us to use an AP and hit it right at the source of capturing traffic for both our wireless interfaces and wire traffic going out of that access point. So we can see, very clearly at that point what's going on in our network and gives us a lot more visibility. Rather than looking at it from the switch point only, now we can look at wireless interfaces without having to put in, some other analyzer over the air. We'll let the access point do this for us, and we can save that to a local file that we can download and look at, at our leisure, or we can stream it real time to a Wireshark station and let that collect data real time as traffic's moving through the access point. So that does conclude the demonstration for this feature. Remember, this is part of a series of features for SmartZoneOS 5 of some of the new features that are available in this release for your SmartZone network controller. Hope this information was helpful to you, and hopefully you'll come back and view more of these demonstrations in the future. Thank you.